Hey guys, so this is going to be a quick instructional video kind of piggybacking off of simplifying non-perfect squares or radicals. I'm going to be kind of interchanging using those, the word radical and non-perfect squares. They mean the same thing, okay? But with variables this time. So you guys had practice on simplifying radicals, just the numbers under the radical symbol, right? But now we're actually going to involve some variables, meaning letters, right? So I want to first kind of talk about this example here where it has a square root of 4 squared. Now that square root symbol or the radical symbol, right, that's kind of like something that we're performing on the 4 squared. Now the radical symbol and squaring whatever you have as your base, so in this case my base is 4, those are opposite operations, meaning they undo each other, right? So if you think about it, if you actually square 4 squared, that gives you 16, and then we know the square root of 16, that's a perfect square, and that would just give us 4. Meaning, whenever you square something, right, whatever your base is and you have a radical over it, those essentially just cancel each other out and you're left with whatever the base is. So that idea I want to kind of tie into when we're going to be simplifying our radicals with variables, right? Our variables are going to be be x, they can be a, they can be b, they can really be whatever letter. Okay, so I'm going to give you guys a couple different examples here. So if they're asking you, okay, what's the square root of x squared? Again, the radical and the 2, that exponent 2, they cancel each other out. I would just be left with x. Okay, same idea here. If I was taking the square root of a squared, right, the radical and the 2, they cancel each other out. I'm left with a, and then the square root of b squared, the radical and the exponent of 2 cancel each other out. You're left with b. Okay, so now what happens when you're left with the number under the radical where that exponent is bigger than 2, or it's not 2, right? So for example, as I have x to the 4th power, the square root of that, essentially what you're doing is you're breaking that up as x squared times x squared, or the square root of x squared times the square root of x squared, right? And we already know that we did this example up here, right? The square root of x squared, that cancels out and I just have x. Another square root of x squared, that cancels out and I'm left with x. And I'm left with x times x, which is just x squared, okay? You're going to notice a pattern as I do 1, 2, and 3, and I'm going to kind of show you a quick shortcut, all right? So again, if I want to break up x to the 6th power, that'd be the same thing as x to the 2nd times x to the 2nd times x to the 2nd, right? Because 2 plus 2 plus 2 gives me the 6. And again, separating those, I have square root of x squared times square root of x squared times square root of x squared. And that's going to turn into x times x times x. And x times x times x would give me x to the 3rd power. So some of you might be picking up on the pattern that essentially what you're going to do anytime you have an even number for an exponent under the radical, you're just going to divide it by 2. Okay, so if I have square root of x to the 4th, well, 4 divided by 2 is 2. I'm left with just x squared. X to the 6th, 6 divided by 2 is 3. I'm left with x to the 3rd. And this was supposed to be, x to the 8th, my bad, okay? So again, kind of doing your quick shortcut, you're just taking that even number of 8, you're doing 8 divided by 2, which gives you 4, which meaning this is going to equal x to the 4th power. Okay, so it's nice and easy when you have even numbers. Now, when you have odd numbers, you're essentially going to have like what you think of a remainder left under your radical, right? So I can break this up here. I'm going to do my little breaking up as x squared times x squared times just plain old x, right, or x to the 1 power, because 2 plus 2 plus 1 gives you the 5. So again, we know that there's going to be square root of x squared times square root of x squared times the square root of x, or x to the 1 power. Now I know this is going to turn into an x, right, times that's going to turn into an x, and then I'm left over with radical x. So this simplified x times x gives me x squared, and I'm going to have 1x left over remaining under my radical. Now here's the key, guys. Anytime you do have an odd number, or whatever that odd number is, that means you're always going to have that base, whatever it is, left under the radical. But it's not going to be raised to a power. It should always just be by itself, right? So again, using your shortcut, you're essentially now thinking, okay, well, how many times does 2 go evenly into 7? All right, well, I think on my fingers, 2, 4, 6, 3 times. So meaning there's going to equal x to the 3rd power, but since it's an odd number, I'm going to have a remainder of x under my radical. If you didn't follow what I just did there, you can kind of just do the breaking up again, right? It'd be x squared times x squared times x squared times x. Those 3x squares would just turn into x to the third, and then a leftover of radical x, okay? Now again, my shortcut here, thinking of how many times 2 goes into 9 evenly, right? That'd be 2, 4, 6, 8. So I'm going to have x to the fourth, and then since it's odd, I have just an x as a remainder under my radical. Okay, so here's your idea. Anytime it's an even number, you're not going to have any x left under the radical. It's just going to be whatever that exponent is divided by 2. And then anytime you have an odd number, you're going to at least have that base left over under the radical. Okay, now kind of tying in the idea of, okay, you guys can see different letters as bases, and you can have multiple at a time. Okay, so I like to kind of break it up. So if I had this, I can rewrite this as a square root of a squared times a square root of b to the fifth. Now the square root of a squared, that's just going to turn into an a, right? And then b to the fifth, I'm thinking how many times does 2 go into 5? So 2, 4, twice. That's going to be times b squared. And since it's an odd number, right, 5 is odd, I'm going to have a b left over. So it's going to turn into ab squared and then radical b. Okay? Looking at number 8, so again, looking at my base of a, the exponent is odd 13. So 2 goes into 13 evenly 6 times. Right, so I'm just going to kind of write this as a to the 6, and since it's odd, I'll have 1 left over. And then for my b, so times, since 20 is even, right, 2 goes into 20 evenly 10 times. So it's going to just be b to the 10th with no b left under the radical, right, because 20 is an even number. So writing this as my final answer, whatever is not under a radical goes out front. So it's going to be a to the 6, b to the 10th, and then just with that radical a left over next to it. Okay. All right, and my last one, number 9 in this row. So looking at this is nice because both 8 and 30 are even numbers. So 8 divided by 2 is 4. So I have a to the 4th. And then 30 divided by 2 is 15. So b to the 15th. No variables left underneath the radical there. Okay. Now your final step is tying it in with the number and the variable, right? So it's kind of just throwing in that extra step. So I can write this as radical 8 times radical x to the 4th times radical y to the 7th. You guys don't need to break it up like this. I think it's just easier to kind of break down the problem to see what you guys are doing. If you can mentally kind of do these problems, that's fine too. Okay, but breaking up my radical 8, I know that'd be radical 4 times radical 2. I know my square root of 4 is just 2, so I'm left with 2 root 2. Okay, let me just break these up a little bit here. Now since 4 is even, right, 4 divided by 2 is 2, so there's just going to turn into x squared. And then for my y to the 7th, 7 is odd. So 2 goes into 7 evenly 3 times. That's going to be y to the 3rd. And since it is in fact odd, I'm going to have the leftover of y under my radical. Now again, rewriting this as one solid answer, all the numbers or the variables that do not have a radical over them go out first. So I'll have 2, right, x squared, y cubed. And then under my radical, I'm going to have 2y. You can kind of just put those right next to each other together. Okay, so you have that nice answer of 2x squared y to the 3rd square root of 2y. Okay? All right, for 45, so I'm going to break this up as radical 45 times radical a to the 9th times radical b to the 14th. So 45, I can use 9 and 5. Square root of 9, square root of 5. I know the square root of 9 is just 3, so I have 3 root 5. Okay, 9 is an odd number, right? So that means 2 go from the 9 evenly 4 times. So I'm going to have a to the 4th, and then a leftover of a under the radical, because again, the exponent is odd, so meaning I'm going to have a leftover of 1 under there. And then 14's even, so again, 14 divided by 2 just leaves with me b to the 7th power. Now again, putting this all together, I'm going to have my 3, a to the 4th, b to the 7 first. So 3, a to the 4th, b to the 7. Then under my radical, I'm going to put together the 5 and the a. So 5a. Just like that. Okay? And my last one for 80. Okay, so 80 is kind of a big number, and again, I think a lot of you guys want to use like 4 and 20. The biggest perfect square that goes into 80. Okay, so you guys can just kind of run through your perfect squares. 25 I know doesn't go into 80, right, because 25 goes into 75. Let me try 16 though. So 80 divided by 16 gives me 5. So I can break down radical 80 as radical 16 times radical 5. I know the square root of 16 is just 4, so that 80 breaks down to 4 root 5. Okay, now radical A, that's just kind of my leftover. There's no exponent power there, so I'm not going to touch that. I'm just going to leave that under the radical. And then radical B cubed, 2 goes into 3 evenly once, right? So I'm just going to have a B, or B to the 1 power, and then with the leftover of B under my radical there. Okay, so I'm putting together the 4 radical 5, the radical A, and then the B radical B. So out front, I'm going to have the 4 and the B, right? So 4B, and then square root of 5AB. 5